Hello students, all students are welcome to my chemistry class. Today I will discuss about the balancing of chemical equation through oxidation number method. In the previous class we have discussed how the oxidation number of the element in a compound can be determined. Today I will discuss the balancing of chemical equation through the help of oxidation number method. Suppose the reaction is, I have taken a reaction Na2 plus HCl, MnCl2, Cl2 plus H2. Here you see, you have to find out which element involved in the change of oxidation number. You see, manganese here and here. Here the oxidation number of manganese is +4. But here the manganese in +2 state. Another element is chlorine. Here is -1, but here is 0. You see, the oxidation number of manganese is decreased by 2 elements. So here I can write oxidation number decreased by 2 elements. Here you see, from HCl to chlorine, the oxidation number has been changed for each atom is 1. But to get one chlorine molecule, the change of oxidation number as a whole is 2. But we learned here the oxidation number increases for one atom equals to 1. So at least one chlorine molecule will be produced considering these factors. 2 chlorine atoms, the increase of oxidation number for 2 chlorine atoms is 2. So the change of oxidation number is here. Alright. But, so you get MnO2 plus 2HCl to MnCl2 Cl2 plus H2. But I see in manganese chloride 2 chlorine atoms are required. So to supply these chlorine atoms, 2 additional HCl is to be added in the reaction. So the balance equation is MnO2 plus 4HCl MnCl2 plus Cl plus 2H2. These HCl are required for salt forming. In these cases, the oxidation number of chlorine does not change. But which chlorine atoms oxidize to chlorine molecule, in this case, the oxidation number is increased by 1 unit for 1 chlorine atom. I am taking another example. In this reaction, you see oxidation number of nitrogen in nitric acid is +5, whereas that of sulfur in H2S is -2. Sulfur here in the element condition, hence it is 0, and nitric oxide, nitrogen is in +2 oxidation state. So the increase of oxidation number for one sulfur atom two, and decrease of oxidation number for one nitrogen atom three. So you have to multiply this portion by 3 and this portion by 2. So the equation becomes 2H3 plus 3H2H 3S plus 2NO 4H2. I'm taking another example. When acidified potassium carbonate reacts with ferrous sulfate solution, it oxidizes ferrous sulfate to ferric sulfate, and potassium carbonate is reduced to manganese sulfate. You see, in this case, the oxidation of manganese here is +7, and that of iron is here +2. Here manganese is +2, and here iron is +3. So decrease of oxidation number of manganese, decrease of oxidation number equals to 5 here, and here increase is from here to here, increase of oxidation number 1 for 2 iron atom, because to get 1 ferric sulfate molecule, 2 iron atoms is required. So to get a molecule of ferric sulfate, 2 iron atoms is required. So the net increase is oxidation number +2 into 2 to +3 into 2, that means +4 to +6, that is 2. So 2 for 2 iron atom, increase of oxidation number equals to 2. But for 1 manganese atom, decrease equals to 5. So you have to multiply here 5 and here 2 to equate the change of oxidation number. That means the increase of oxidation number and decrease of oxidation number should be same. You have to multiply here 2. So 2 kmol plus H2SO4 plus 10 FeSO4 K2SO4 plus 2 NiSO4 plus 5 K2SO4 plus H2. There is some problem. We did not get the number of sulfate equated in both sides, because the salt forming sulfate, that means you see in the right hand side, potassium sulfate requires 1 sulfate, manganese sulfate 2, that means 3, and ferric sulfate requires 15. So total sulfate is 15 plus 3, 18. You see here is 10 sulfate. So additional 8 sulfate is required. So the balance equation will be 2K-4 plus 8H2SO4 plus 10 FeSO4 to K2SO4 plus 2 MnSO4 plus 5 K2SO4 plus as the left hand side 8H2, that means 8H2. This is the balance equation for this reaction. Here I am giving another example. Acidified potassium dichromate solution oxidizes potassium iodide into iodine, and it gets reduced to chromic sulfate. You see, in this case, the oxidation number of chromium here is +6, iodine here is -1, iodine here is 0, and chromium here is +3. So the oxidation number increase of iodine for one atom, increase of oxidation number of 1, decrease of oxidation number for one chromium atom, +6 to +3. So decrease of oxidation number of chromium is 3. But get one molecule of chromic sulfate, you have to use 2 chromium atom, and to get 1 molecule of iodine, you have to take 2 potassium iodide. So 2 iodine increase 2, and for 2 chromium atom, decrease is actually 6. Increase of oxidation number and decrease of oxidation number, you have to multiply here 3. So the balance equation will be K2Cl2O7 plus 6Ki plus H2SO4 K2SO4 plus 3I plus K2SO4 plus H2. So salt forming sulfate is here, total in right hand side 4. So you have to take 4 H2SO4. So this is not the balance equation. Actually balance equation is H2SO7 plus 6Ki plus 4 H2SO4 K2SO4 plus 3I plus K2SO4 plus 4H2. This is the balance equation for this gas. I am taking another example. When phosphorus is treated with NOH solution, phosphorus is reduced to phosphine, and at the same time it is also oxidized to sodium hydrogen phosphide, NH2PO. So here you see, this is the reaction, phosphorus. Here it is reduced and here it is oxidized. In this case, oxidation number is -3, and in this case, oxidation number is +1. So for one phosphorus atom, the increase of oxidation number equals to 1, and decrease of oxidation number equals to 3. So you have to multiply this portion 3. So initially 4 phosphorus atom is here in the P4 molecule. So as a whole 3 phosphorus is involved here and 1 is involved here. As a total phosphorus required is 4. So it is okay. And with the balance equation, you have to multiply in this portion 3. So you have to multiply here 3, but not here 3. Okay. So the balance equation will be P4 plus NOH plus H2, P3 plus 3 NaH2PO. To adjust the number of atoms of hydrogen, 3 Na, this is 3, and here is also 3. So this is the balance reaction. These numbers you cannot get from oxidation number method, you have to adjust it. Okay. Seeing the number of hydrogen atoms in the right hand side, you have to adjust the number of hydrogen atoms in the left hand side also. So this is the balance equation for this type of reaction is also called disproportional reaction or dismutation reaction. Okay. Disproportional reaction or dismutation. Both terms are used in chemistry. And take another example. You see, in this example, this bromine atom is oxidation number +5, but for this bromine atom it is -1. Here you see bromine is in molecular form, so it's 0. Bromine here is decreased and also increased to same condition of bromine. Okay. That is in 0 oxidation state. So, for one bromine atom, decrease of oxidation number here equals to 5, and here you see increase of oxidation number equals to 1. So you have to multiply this portion 5. So bromide is required 1 molecule and potassium bromide is required 5 molecule. Ultimately you will get 3 reactor molecules. So the balance equation is like this: KVPY 3 plus 5 KVPY. Adjust the number of H2 molecule, you have to adjust 3 oxygens here, so 3 H2 molecule will be produced, so 6 HCl is required. Okay. So the balance equation is KVR 3 plus 5 KVR plus 6 HCl. Plus CH2. So this is the balance equation for this reaction. So this type of reaction is called comproportional reaction. You see here, in the reactant side, bromine atoms in potassium bromide and in potassium bromide are in different oxidation state. Both are simultaneously oxidized and reduced to bromine. The same oxidation state of 0. Okay. So when two different oxidation state of an element in different conditions by reaction generate same oxidation state, that type of reaction is called comproportional reaction. So this is called comproportional reaction. The reverse of disproportional reaction. Okay. In disproportional reaction, one oxidation is changed to increased and decreased as well. But in proportional reaction, different oxidation state, one is increased and one is decreased to same state of oxidation state of the element. This type of reaction is called comproportional reaction. So this is all about balancing the chemical equation by oxidation number method. Thanks to all viewers for viewing my channel and attending my chemistry class. You are always welcome to my channel. Thank you.